Hello, today we are going to learn about the Fulagar, a special ship in the history of shipbuilding. It was the first ship built entirely using welding instead of rivets. It was launched in 1920 and was used to transport goods between Liverpool and Cardiff in England. At first glance, it looked like just another cargo ship of its time. However, it was an experimental project created to test a new construction method that did away with traditional metal rivets. Because it was such a novelty at the time, the ship was subject to strict annual inspections. There were doubts about whether welding would be strong and safe enough to withstand the demands of the sea. Thanks to the archives of Lloyd's Register, the organization responsible for registering and inspecting ships, we now have access to technical drawings, reports, and correspondence related to the Fulagar. In front of you, you can see one of the technical drawings of the welded iron plates that formed the ship's structure. These drawings show how the plates were joined and reinforced. Here you can also see a 3D representation of the Fulagar, which helps us imagine what this ship looked like as it sailed between Liverpool and Cardiff. Let's explore the history of this ship. On this page, you can see more technical drawings of the Fulagar, like a boiler diagram, showing how steam was produced to power steam-driven equipment. You can also see the ship's profile drawing, where you can observe its shape, and a plan detailing the location of the engine, as well as other important areas on board. All these drawings contain very interesting details. You can zoom in on the images to read the text more carefully and closely observe these shipbuilding documents, created between 1918 and 1919. These records help us better understand how the Fulagar was designed, structured, and built. In the records of Lloyd's Register, a 1921 memorandum about a report by Mr. Campbell Holmes states,
A report has now been received from Mr. Campbell Holmes regarding his examination of the SS Fulagar, together with a statement showing the service on which the vessel has been engaged since the date of build. From the statement, it would appear that the vessel has been actually engaged in service for about 4 months and performed 27 voyages between Liverpool and Cardiff. In 6 of these runs, she carried no cargo. In 9, she had a full cargo of steel plates. In 1, a full cargo of coal. In 2, a full general cargo, and in the remainder part cargoes. It is reported that in some of these voyages very heavy weather was encountered, but no damage was sustained. Since December last, the vessel has been laid up while a new type of motor was being installed. Mr. Holmes made a careful examination of the vessel and reports that there is no signs of straining of the welded joints. There is local corrosion here and there in some of the hollows of the deck plating, but the welded material has rusted no more than other parts. Mr. Holmes is of opinion that sufficient experience has not yet been gained to justify the removal of the notation experimental at present recorded in the register book. It is accordingly suggested that the conclusions given in the endorsement of the 12th October be adhered to.
But in 1924, something unexpected happened. The Fulagar suffered an accident, clipping state.
In June 1924, a serious accident occurred to the vessel which has in a striking manner proved the superiority of a ship welded with quasi-arc electrodes over a riveted ship. The vessel went aground on a sandbank in the Mersey during a voyage from Liverpool to Belfast, when fully laden. She floated off on the next tide, and as she was perfectly watertight, proceeded on her voyage and discharged her cargo at Belfast. It was then found that she was damaged to a considerable extent, but as the shell was watertight, it was decided to take her back to Liverpool under her own power. When docked, the vessel was thoroughly examined, and by using sights, the bottom was found to be set up 11 inches from bilge to bilge over a length of roughly 70 feet. And from the evidence of inside structural work, she had been set up more, but had settled when placed on the blocks. A remarkable test.
According to correspondence from Lloyd's Register, the ship was renamed Carrier and put up for sale. The document states,
Dear Sir, I have the honour to return here with report of survey as below, recently forwarded to us for guidance in the survey of the vessel. Vessel Carrier, ex-Fullergar. Vessel laid up for sale in damaged condition.
Soon, the ship will be about to begin a long journey to its next owners. In 1924, the same year as its first accident, the Falaga would be sold to a cement company in Vancouver, Canada. A Lloyd's register letter confirms.
As this vessel is not classed for any restricted trading, I see no reason why she should not make the trip to Vancouver.
However, before making this long journey, the ship had to be inspected and pass the freeboard test. Freeboard is a technical term, and we will discover its meaning later. This Lloyd's Register letter regarding the inspection is a vital instrument for ship safety and registration, and states,
Dear Sir, I have to inform you that the freeboard marking of the oil engine vessel Carrier has been verified and found in accordance with the freeboard certificates issued when the vessel was named Fullergar. The vessel is now under survey for damage, and on completion it is understood will be purchased by the British Columbia Cement Company, but that the name of the vessel and port of registry are to remain unaltered. New certificates have been requested, and I shall be obliged if you will kindly let me know if any fee is to be charged for these. The original certificates are enclosed.
this confirms the ship would be purchased by a Canadian cement company, likely making the long voyage via the Panama Canal. Freeboard is the vertical distance between the waterline and the deck level on a ship, used to ensure buoyancy margin and stability. The Falaga was sold to the British Columbia Cement Company in Vancouver and was to make the journey from the United Kingdom to Canada. It therefore had to be tested to calculate freeboard and stability for the entire voyage, including crossing the Panama Canal and the Atlantic.
18th century merchant shipping was far more dangerous than it. Lloyd's Register, the Ship Classification Society, introduced the Lloyd's Rule. They recommended that the distance from the waterline to the weather deck should be 3 inches of freeboard per each foot of depth in the hold. Samuel Plimsoll, a British coal merchant and member of Parliament at the time, was shocked by the scale of light lost at sea. In 1874, Lloyd's Register made it a condition of their classification that a load line should be painted on newly built awning deck steamers. This original load line was a diamond with a centre line and the letters LR next to it. This, of course, only applied to ships inspected by Lloyd's Register. In 1876, the Merchant Shipping Act made load lines compulsory on all British vessels and on foreign vessels using British ports. An international solution came with the first International Convention on Load Lines in 1930. In 1966, the International Maritime Organization adopted a new convention ensuring the ship has enough reserve buoyancy, covering the allowed freeboard for a ship in different climate zones and seasons via a load line zones and areas map. The Plimsoll line and the Summer line are the same. All of the lines take their positions from there. TF, tropical freshwater. F, freshwater. T, tropical. S, summer. W, winter. WNA, winter North Atlantic. Winter North Atlantic, being the highest permitted draft given the heavy weather conditions that can be encountered in the Atlantic during the winter. When a ship is commissioned, the exact location of the load line is calculated by a classification society, its position on the hull is verified, and a load line certificate is issued. The chief officer is responsible for the safe loading of the cargo. On a winter route from Greenwich, Glasgow to Ho Chi Minh City, Vietnam, The calculations would need to consider adequate stability for all stages of the voyage and the load line for the route and season. The ship would pass through the Atlantic winter zone and the summer Mediterranean zone. Onto the Suez Canal, Red Sea, the Strait of Malacca, finally arriving in Ho Chi Minh City, which are all in the tropical zone at this time of year. Thanks to the campaigning of Samuel Plimsoll 150 years ago, countless lives and vessels have been saved. Today, the International Maritime Organization and classification societies continue working to improve maritime safety across the globe. 19th century merchant shipping was far more dangerous than it is today.
Meanwhile, the new owners had renamed the ship Xi'an. From 1925, there is a memorandum reminding the ship's new owners in Canada that the Fulagar must undergo its annual inspection. This memorandum states,
Steel motor vessel Xi'an, ex-Korea, ex-Fulagar. This vessel again became due for her annual survey at the end of December 1925.
a letter from A. Scott of Lloyd's Register confirms that in February 1926, he was about to travel to Victoria, Canada, to carry out the ship's inspection.
I have to inform you that I have already received a message from Victoria that the ship is on dry dock and requesting survey of same, and I am leaving for Victoria tonight.
And so the ship's new owners had the inspection carried out and were able to use it for several years before another unforeseen event occurred, which, as we will see, was very bad in one way, but good in another. A 1931 article in the Shipping World titled Welded Joints in Ship Construction, mainly dedicated to the Fulagar, states the Fulagar suffered a serious accident but managed to withstand it because welded joints were stronger than traditional construction.
The new owners, who have renamed the vessel Xi'an, stated that on October 24, 1930, it struck a rock cliff in the Saanich Inlet near Victoria when going at full speed and had 10,000 bags of cement on board. The photographs show the extent of the damage, and on examination it was found that in no case did the plates tear apart at the welds.
The results were quite unexpected.
Had the vessel been riveted, the damage would have no doubt extended beyond the forepeak bulkhead and caused flooding of the cargo space, in which case the cargo would have been irretrievably ruined, whereas less than 400 sacks were damaged. Also, the vessel would have probably sunk, as she had about 16 feet of water under her amidships and further aft. The vessel has since been repaired in strict accordance with her class, has passed her 10th annual survey satisfactorily, and is in good condition. The above is the second occasion on which this vessel has sustained damage which would have resulted in a riveted vessel becoming a total loss.
After surviving this accident, in which the iron plates broke but not the welds, Lloyd's Register agreed to allow the ship to be inspected every 2 years instead of annually. The ship would soon be renamed again and sold. In 1935, an inspection certificate for the ship related to freeboard was issued by Lloyd's Register, titled Survey for Freeboard. That year, the ship was sold to a company in Mexico. A letter from the chief surveyor of Lloyd's Register of Shipping in New York stated,
Motor vessel Cedros, formerly Xi'an. This vessel has been sold to Mexico and will trade between Ensenada and Los Angeles. The hull certificate is made out as before, subject to biennial survey, but in my opinion there does not appear to be any real reason for this, unless it is a standard practice with electrically welded ships.
the ship was sold and made the long journey to Mexico. In that year's freeboard inspection, terms such as deduction for superstructure and shear correction appear, with various calculations beneath them. The terms and calculations present are not easily understood by just anyone. Extensive technical training is required to interpret them. This demonstrates that, already in 1935, Lloyd's inspections were rigorous and highly technical, ensuring safe navigation of vessels. Unfortunately, the final voyage of the Fulaga, now Cedros, took place in 1937. A total loss report was submitted from Ensenada, Mexico, which stated,
This vessel was reported to have sunk after collision with the Hidalgo, 30 miles south of Ensenada, Lower California, Mexico, on the 31st August. Upon inquiry at Lloyd's by telephone today, it was ascertained that the vessel has been accepted by the underwriters as a total loss.
Clippings attached to this report, under Source of Information, state,
Mexican motor vessels, Hidalgo and Cedros, were reported in collision off Ensenada. Former put into Ensenada leaking, latter reported sunk. Owners of the motor vessel Cedros advised total loss by collision with motor vessel Hidalgo. Motor vessel Hidalgo collided with and sank the motor vessel Cedros 30 miles south of here today, and 3 seamen on board the Cedros were trapped below the decks and drowned. 14 passengers were rescued by the Hidalgo from the Cedros, which sank 20 minutes after the collision. The Cedros, southbound toward Mazatlan, was owned by Abelardo Rodriguez, former president of Mexico.
This ends the story of the Fulaga, which over its life proved the effectiveness of welded ship construction. Its final voyage, with the loss of lives and of the ship itself, reveals that even technological advances and rigorous maintenance could not eliminate all the risks of the sea. In 1935, an inspection certificate for the ship related to freeboard was issued by